So in the earlier classes we have studied about the plane surfaces, plane curves and all those things. So what is a, now in this chapter we will learn about polygons, especially about the quadrilaterals, a four-sided polygon. So first of all, what is a polygon? So polygon is a simple closed curve made up of line segments. A simple closed curve you can note it down in your notebook. Polygon, a simple closed curve, a simple closed curve made up of line segments. A simple closed curve made up of only line segments is called as polygon. Example: triangle ABC is a polygon. This is a four-sided polygon. Also called as quadrilaterals. All of you mark your attendance, mark as present, sir, and I will take the attendance and note it down in the register. So a triangle is a polygon, a four-sided figure is a polygon. Now classification of polygons. Classification of polygons. This classification we will do on the basis of number of line segments or the number of vertices. So for the smallest polygon possible is a triangle. We cannot have a polygon with two sides. So simplest polygon, so three sides. A polygon with three sides, we know that it is called as triangle. A three-sided polygon is a triangle. Four-sided polygon is called as quadrilateral. Five-sided polygon is called as pentagon. Six-sided polygon is called as hexagon. Seven-sided polygon is called as septagon. Eight-sided polygon is called as octagon. Nine-sided polygon is called as nonagon, and 10-sided polygon is called as decagon. Or n-sided polygon is called as n-gon. Now diagonals. When we have vertices, we have diagonals also. So what is a diagonal? What is a diagonal? A diagonal is a line segment. Diagonal is a line segment which what is diagonal? It is a line segment. It is a line segment It is a line segment which joins two non-consecutive vertices of the polygon. It is a line segment which joins two non-consecutive vertices of the polygon. Like line segment AC and line segment BD are two diagonals. Of the quadrilateral. This symbol we can use for quadrilateral. So a quadrilateral divides the plane into three parts. A quadrilateral divides the plane into three parts. Interior, exterior, and the quadrilateral. So this is quadrilateral ABCD. This shaded part is called as the interior. This is the quadrilateral and the exterior. Now here we see that interior has a boundary. Interior has a boundary. So the question is, does the exterior have a boundary? Here we see that interior has a boundary. Now the question is whether exterior also has a boundary. You discuss it along with your friends and tell me in the next module. Now the two different types of polygons. Convex polygons and concave polygons. Convex polygon. Convex polygon. Okay, so a polygon whose diagonals lies in the interior. A polygon whose diagonals lies in the interior are called as convex polygons. Examples: a square, a rectangle, a pentagon. All their diagonals in all these three polygons, the diagonal lies in the interior. Diagonals lie in the interior. concave polygon. Polygons whose diagonals or part of diagonals polygons whose diagonals or part of diagonals lie in the exterior are called as concave polygons. So this part here, this part of diagonal lies in the exterior. Such type of polygons are called as concave polygons. This diagonal here, this whole diagonal lies in the exterior. This is on the basis of the diagonals. Now on the basis of angles and sides we will decide whether the polygons are regular or irregular polygons. Regular polygons. Regular polygons. The polygons which have equal sides and equal angles are called as regular polygon. Okay, so examples for regular polygons. The first example which comes to our mind is a square. All the sides are equal and all the angles are equal. All the angles are 90 degrees. Then equilateral triangle, all the sides are equal and all the angles are equal. Regular pentagon, irregular polygons. Polygons which are not regular. Polygons which are not regular that is sides are unequal and angles are not equal are called as irregular polygons. Irregular polygons. Angle-sum property of quadrilaterals. Next topic is angle-sum property of quadrilaterals. angle sum property of quadrilateral. So let us take a quadrilateral first. And let us divide it into two parts. By drawing the diagonal BD. So this is part 1 and this is part 2. This is angle 1, this is angle 2, this is angle 3. So this is angle 1, this is angle 2 up to here, this is angle 3, this is angle 4, this is angle 5 and this is angle 6. We have learned the angle sum property of triangles in the 7th class. Using that we will find out the sum of angle 1, 2 and 6. So angle 1 plus angle 2 plus angle 6 is equals to 180 degrees. Angle sum property of Similarly, in the other triangle, angle 3 plus angle 4 plus angle 5 is equal to 180 degrees. The same reason. Now add equation 1 and equation 2. Angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 will be equal to 360 degrees. When we add angle 2 and 3, as consider angle 2 and angle 3 as single angle, similarly angle 5 and angle 6 as single angle, let us call this as, then we see that the sum of the sum of all the angles of a quadrilateral is the sum of all the angles of a quadrilateral is 360 degrees. Let us write angle 1 as angle A, angle 2 plus angle 3 as angle B, angle 4 as angle C, and angle 5 plus angle 6 as angle D. So angle A plus angle B plus angle C plus angle D is equals to 360 degrees. So what is the angles of property of quadrilaterals? The sum of all the angles, the sum of all the angles of a quadrilateral is 360 degrees. Okay, so first we took a quadrilateral A, B, C, D and we divided it into two triangles by drawing a diagonal and marked the angles as angle 1, angle 2, angle 3, angle 4, angle 5 and angle 6. Now in triangle ABD, angle 1 plus angle 2 plus angle 6, angle 1 plus angle 2 plus angle 6 is 180 degrees, because we have already learned the angles and property of triangles. Similarly, in triangle BCD, angle 3 plus angle 4 plus angle 5 is 180 degrees because of angles and property of triangles. Now add both the equations, equation 1 and equation 2, we get angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 is equals to 360 degrees. Or in other words, let us take angle 1 as A, angle 2 plus angle 3 as angle B, angle 4 as angle C and angle 5 plus angle 6 as angle D. Then we can write like this: angle A plus B plus C plus D is equals to 360 degree. This is called as angle sum property of quadrilaterals. Exterior and next is exterior angles of a polygon. Exterior angle property. So here this is an equilateral triangle because all the sides are equal and all the angles will be equal, that is 60 degrees each. Now what we have to do, we have to find out the sum of angle 1, angle 2 and angle 3. So since this is a linear pair, angle 1 will be equal to 120, angle 2 will also be equal to 120 and angle 3 will also be equal to 120 because all the three are linear pairs. So angle 1 plus angle 2 plus angle 3 is equals to 360 degrees. Similarly here all the angles are equal, that is 90 degrees each, and these angles will also be 90 degrees because linear pair. So angle 1 plus angle 2 plus angle 3 plus angle 4, angle 1 plus angle 2 plus angle 3 plus angle 4 is equals to 360 degree. So we can say that sum of the measures of the measures of the exterior angle of a polygon is (360 degrees). Kinds of quadrilaterals. First one, trapezium. It is a quadrilateral which have a pair of which have a pair of parallel lines. Examples: okay, so that's all for today's module, and we will continue in the next module. Remaining kinds of quadrilaterals we will continue in the next module. Thank you. Doubts? Any doubts? If you have any doubt, you can ask in the live comment section. Yes, there is a question, sir. Can we write the notes? Yes, you can write down the notes.